Hi everyone! Today we'll be walking you through a traffic simulation system designed to optimize travel routes and traffic light timings. This pseudocode is part of a project to simulate traffic flow between intersections, helping drivers find the fastest path while considering factors like vehicle density, speed, and emergency vehicles. Let's dive into the code and see how it works.
Hello everyone, before I start explaining about the program flow explanation of optimizing traffic flow in a smart city, I would like to introduce myself. My name is Adela Chinandrian. So before that, there are three processes of program flow explanation. Number one is input, where the input is current hour to check if it's rush hour, and for each road there are vehicle density, average speed, and emergency status. And second of all, there is process. For the process, there is estimated travel time for each route segment, considering rush hour and emergency vehicles. In this process also, we evaluate possible routes from point A to D. This is recommended green light durations during vehicle density. For the third one is output. This output is searching for the fastest route and total travel time. Suggested green light duration per.
So first of all, let's start by looking at the overall structure of the code. At the heart of the system is a dictionary called roads. This dictionary stores information about each road connecting two intersections. For example, from A to B or B to C. Each entry includes the useful data like the distance in kilometers, the traffic density on the scale from 0 to 100, the average vehicle speed, and whether there's an emergency vehicle on that road or not. This data helps us simulate traffic in a realistic way and allows the systems to make smart decisions about route planning and traffic light timings. There are several key functions in the system. For example, the first one is get road data, which is to retrieve data for a specific road segment. The second one is input road data. It's for the user to enter the traffic data for each road. The third one is estimate time. It calculates how long it will take to travel a road based on the speed, traffic, and other factors. And the fourth one is the green light direction. It suggests how long traffic lights should stay green based on the current condition. And the last one is find fastest path, which is to search all possible routes and find the fastest one. The main function ties everything together. It takes the user's inputs, runs the simulation, and shows the final result. As you can see here on the code, this is what the dictionary looks like. For example, the road from A to B is 10 kilometers long and has zero traffic right now and no emergency vehicles, and so on. The getRoadData function is used to retrieve traffic data for any two connected intersections. Roads can be traveled in both directions, so the function checks for both A to B and B to A. If the road exists in the dictionary, it returns the data. If not, it lets the calling function handle it.
Zoom in into the first two functions. This function retrieves road data for a given start and end intersection. Since road can be traveled in both directions, it checks for both start end and end start in the road's dictionary. If the road exists, it returns the associated data. Otherwise, it will be handled by the calling function. The second function prompts the user to input traffic data for each road. For every road, it asks for vehicle density from 1 until 100, average speed in kilometer per hour, emergency vehicle status, either yes or no. It includes input validation. Density must be between 1 and 100, speed must be positive, and input must be numeric. If the user enters invalid data, it raises a value error and prompts them to try again. This ensures the simulation works with realistic data. Next, let's look at how travel time and travel light durations are calculated. So this function estimates the time travel for a road segment. It uses the formula time equals distance divided by speed per 60. To convert the result into minutes during rush hours 7 until 9 a.m. or 5 till 7 p.m. It adds 20% time penalty. If an emergency vehicle is present, it reduces the time by 5 minutes to simulate priority passage. This result is rounded to 2 decimal places for clarity. The next function calculates the green light duration based on vehicle density. It returns a value between 30 seconds minimum and 120 seconds maximum, scaled by the density. For example, a density of 50 out of 100 would result in a 75-second green light, balancing traffic flow.
Now let me explain the green light duration function. The purpose of this function is to determine how long a green light should stay on based on the density of the vehicles of the road. The function takes one input, road data, which is expected to include density value. Inside the function, we use min 120, max 30 road data density. So this ensures that the minimum green light time is 30 seconds even if the density is low, and the maximum is 120 seconds even in heavy traffics. So the actual green light duration will be proportional to the vehicle density. So for example, if the density is 50, the result will be 50. If the density is below 30, like 20, it will return to 30, and if it's above 120, like 150, it will return to 120. This logic helps to create a more dynamic and responsive traffic signal system. Let's now take a look at finding the fastest path function. This function evaluates multiple routes and returns the fastest one based on the estimated travel time. So here's the step-by-step breakdown. First one, there is input. The function accepts a parameter rush hour, which by default is set to false. This allows the function to adjust travel times based on rush hour conditions. And then the second one, there is route options. A list called paths defines all possible routes from point A to point D. For example, route 1 from A to B to D, route 2 from A to C to D, and then there's route 3 from A to B to C to D. And then the third one, there is initialization. Best time is initially set to infinity, so any real travel time will be lower. Best path will store the fastest route, and path details collects data for each evaluated route. And then the fourth one, main loop, to evaluate each route. For each route, the function initializes the total travel time, loops through every segment in the path, and uses a function getRoadData to retrieve traffic data between 2 points, and then estimated time calculates how long that the segment will take considering rush hour if enabled, and then the segment time is added to total time, and a detail log is created, like from A to B is 12.5 and stored. And then the fifth one, there is tracking the best route. So if the current total time is less than the best time found so far, we update the best time and best path. And then the last one, return values. This function is to return the best path, the travel time, and the detailed segment info.
For the next, I will be explaining about the function to display green light suggestions. In this function, it is used for our traffic simulation system. This function optimizes traffic flow by suggesting green light durations for each route based on its vehicle density. It loops through the road dictionary, which stores road data like density and calls green light duration to calculate duration between 30 and 120 seconds. Next, I'll be explaining about the display results, where we explore the main function of our traffic simulation system. This function is the program's core, orchestrating a simulation to find the fastest route from the intersection A to D and suggest green light durations. It works in 5 steps. For the first one, we prompt the users for the current hour, which is 0 to 23, to check for rush hour between 7 to 9 a.m. or 5 to 7 p.m. Next, we collect traffic data like vehicle density and speed using input data, road data. Then we calculate the fastest route with find fastest path, factoring in rush hours and emergency vehicles. Then displays the route with segment times like A to B, which is 12 minutes, and the total time. And for the last one, we suggest green light durations based on density using suggest traffic light durations.